Hey folks, this second video is all about algebra, so I'm going to solve 4 algebra problems without having any physics content in here. So we have this first equation, f equals g times big M times little m over r squared. We're going to solve this for m. And so this one is going to be our most straightforward. I'm going to write it again, but the way I'm going to write it is with m separated out, because I'm going to want to solve for that. So I'm going to write this as f equals g big M over r squared times little m. And so you can do this in a couple little steps, but I want you to get comfortable with using just one big step whenever possible. So I'm going to take this entire equation, and if I wanted to solve for little m, I need to isolate it by getting these other variables over the other side. Well, these variables are multiplied and divided together, and so I'm going to use multiplication and division to move them to the other side. When you do algebra, when you use multiplication and division, you are essentially just multiplying by the reciprocal of each variable. So if we have g big M over r squared here, and I want to move it to the other side, I'm going to multiply both sides by r squared over g times big M. And when I do that, all of these variables here cancel from the right side, but none of them cancel to the left side. So they just all multiply by big F. So I'm going to have big F r squared over gm, big M rather, equals little m. And that's it. Now you could have divided each side by g, and then divided each side by m, and then multiplied each side by r squared, but you could just get rid of those variables all at once by doing this one step. All right. Next up, we have an equation that has this little symbol, which we call prime, and we'll get to what that means later. So we have I prime equals ICM plus MD squared. We're going to solve it for D. Now, subscripts belong to the big variable, so C and M are not variables, they're just a label on I. Same thing with the prime, it's just a label on that I. And so I just need to do my order of operations here, and I want to solve for D. So the first thing I'm going to do, and I'm going to do this more formally than the last one, is I'm going to subtract ICM from both sides. And so when I'm done, I have I prime minus ICM equals MD squared. All right. One step closer. So the next step is I have md squared. I want to solve this for just d. So multiplied by m, I'm going to divide both sides by m. And so I am left with I prime minus ICM over big M equals d squared. Now, that fraction on the left is pretty messy looking already. I would encourage you in this course to not simplify things unless it's obvious how to simplify it. That is not the focus of the math in this course. It's really just to do correct algebra with the physics that you know, not to do anything fancy. All right, last one, I have d squared. And so to solve for d, I would take the square root of both sides. And so I can now write my final expression, d equals the square root of I prime minus ICM all over big M. Okay, again, no attempt to simplify because you can't, and that's that. All right, I have some other questions on the summer assignment that relate to substitution of variables, and so I haven't written many words about them, but I have a couple of problems to go through. So here we go. So if k equals IW squared and v equals RW, solve for k in terms of v. Okay, so I didn't say that correctly. This W is actually a Greek letter, omega, but I'm going to call it W just for simplicity. All right, solve for k in terms of v. This phrase is going to pop up a lot when we do algebra. To say k in terms of v is to say that I have an equation that has k equals on one side, and then somewhere in the right-hand side is the letter v. And that letter has to appear on that side of the equation. So that's what in terms of means. If k and v are both variables, this equation is going to show how v affects the value of k. Okay, so I'm going to start with k equals 1/2 iw squared. If I'm going to perform a substitution, then I need this equation to have been solved for one of these variables. So I'm going to then move to v equals rw. And if the only link between these two equations is this w. And so what I'm going to do is I'm going to solve this equation for w. So I have w equals v over r. Right, now this is really important. V over r is the same thing as w. And so I'm going to take this expression, I'm going to put it in where the w is. So I'm going to have k equals 1/2 I, and then I'm going to start parentheses, v over r squared. And honestly, that's it. Again, like, you can simplify this expression, but you don't need to. This expression is now k in terms of v. It's an expression that's solved for k and that has v in it, and so we're done. All right. Last one has to do with ratios. This is something that pops up all the time in AP Physics 1, finding the ratio between two variables. The context here is that you imagine like doing separate trials of something, and you want to compare one trial to the other. And so in this case, it's this big equation that you saw in the first problem. F1 and F2 are the two trials, and I'm going to find the value of F1 over F2. And there's no like fancy trick here. If you want to find F1 over F2, you just plug in the equations into a fraction. So F1 is g m1 m3 over r1 squared. And then F2 is big G m2 m3 over r2 squared. Now, all these subscripts are a mess. And this fraction is also a mess. So the first thing I'm going to do is I'm going to simplify this fraction. When you divide by something, you multiply by its reciprocal. So I'm going to take this top fraction and rewrite it. G m1 m3 over r1 squared. And then I'm going to take this fraction in the denominator, I'm going to flip it over because we're multiplying by the reciprocal. So we have r2 squared over g m2 m3. And it's still a lot, but it's now something that we can look at and analyze pretty easily. So I look for like things in common on the numerator and denominator, and I find that big G is in both numerator and denominator. I also find that m3 is in both numerator and denominator. The m1 doesn't have a match on the denominator, neither does the r1 or r2. So I can now compile all this into my final answer. So the ratio between f1 and f2 is whatever's on the numerator divided by whatever's on the denominator. I'm going to arrange it according to the variables. So I'm going to have m1 times r2 squared divided by m2 times r1 squared. So that's it. Now, sometimes you'll have numbers that you then plug in. Maybe later I tell you that like m2 is double the mass of m1 or something like that, and you can perform another substitution. But really, this is like solving for a ratio. All right, see you in the next video.